All right, this is Honors Algebra 2 Pre-Calculus. We're doing 8.7 in Algebra 2, which is simplifying radical expressions, and this is our last video in this section. So fully simplified radical expressions can't have roots in the denominator. We remove radicals from the denominator in a process called rationalizing the denominator, which basically means we make the denominator a rational, not irrational expression. So for denominators with a single root by itself, we just multiply the entire fraction by the root over itself. So if you have a 1 over a root 5, to get rid of the root in the bottom, you multiply by root 5 over root 5, and that'll give you root 5 over 5, right? For denominators that have a binomial expression involving a root, what we need to do is create a difference of the squares pattern by multiplying by the conjugate of the denominator. So if the denominator is 2 plus root 7, we multiply by 2 minus root 7, right? The easiest way to think about this is what you're doing is changing the sign in between the two terms. So you're not changing the sign of the whole expression. If the two terms are a sum, you make sure that you write the two terms as a difference, right? So I could say it's always changing the sign of the root, but the root's not always the second term. It's easier to think about it that you're changing the sign of the between the two terms, right? So if it's a plus b, you multiply by a minus b. If it's a minus b, you multiply by a plus b. So what you'll notice is when we do that, excuse me. When you multiply 2 plus root 7 by 2 minus root 7, the oi, the outer and inner, are going to cancel. So what's going to happen is you're going to get 2 times 2, which is a 4. And then the last term is just going to end up being a minus 7 because it's root 7 times root 7. So no roots, and you're going to get a 2 minus root 7 on top and a negative 3. See how that's not a root on the bottom. Right, so and the same thing happened here, right? Not a root on the bottom. It doesn't mean that you don't have a root in the problem. You still have a root. It's just in the numerator, not the denominator. All right, so we're going to go ahead and fully simplify the radical expression. I have a root 3 on the bottom. The way I get rid of that is by multiplying by root 3 over root 3. So I get that this is a root 3 over a root 9 or root 3 over 3. It is not a terrible thing to memorize. So it is useful to know that 1 over the square root of x is the same as root x over x. Like if you rationalize, it's a root x over x. Or 1 over the square root of a is the same as root a over a. It comes up often enough. This comes up a lot. So it's not wrong to me. That's not quite how I meant to write a lot. That's like a lot, but you know. This comes up a lot. All right, enough so that it's not like it's wrong. If you have to multiply this when you see root 3, or when you see 1 over root 3, if you have to multiply by root 3 over root 3 every time to get to this answer, that's fine. But it does come up a lot. It's kind of useful to just know what happens. So I wouldn't consider it cheating if you saw this and just got here with no work. Like if you get that that's the pattern and you see it happen enough times and you can jump to this and know that these two things are equal to each other, I don't consider that cheating. That's just great. Now the second one's a little bit harder because it's a binomial. So remember, I have this a plus b. What I want to do is I intentionally want to multiply by a minus b. I want to create a difference of squares. So I'm going to multiply by 1 minus root 3 on the top and 1 minus root 3 on the bottom, and then I'm going to FOIL out my difference of squares, right? So when I do that, the top is just a 2 minus 2 root 3, right? I can't multiply the 2 into the root because things inside the root can't be multiplied with things outside the root. On the bottom, when I FOIL, my first term is a 1 times a 1, so that's just a 1. Outer is going to be a minus root 3. Inner is going to be a plus root 3. This is how you know you did this right, because the oi sums to 0, right? The oi should cancel. And then my last term is going to be a minus 3. And if you need to write it as a root 9 first and then realize that root 9 is a 3, that's fine. But that's the idea. So I end up getting that this is a 2 minus 2 root 3 on the top. And on the bottom, I just get a 1 minus 3, which is a negative 2. So I can actually clean this up and make this a 2 over negative 2 minus a 2 root 3 over negative 2. So I'm pretty sure I get negative 1 plus root 3, right? Again, I can't divide into the root, but I can simplify the number in front of the root. All right, let's go ahead and try one. So again, if you're able to look at this, if you can jump to this being 3 root 5 over 5, nobody thinks you're cheating. If you can't, that's also okay. So I'm going to multiply by root 5 over root 5. When I do that, the top is a 3 root 5. The bottom is a root 25, which is how I get 3 root 5 all over a 5. when I get down to b, I have a minus b here. So what I need to do to create a difference of squares is multiply by a plus b. So I'm going to multiply both the top and the bottom by 3 plus root 2, right? And when I do that, the top is going to be a negative 42 minus 14 root 2. I can't multiply the 14 into the root 2. When I FOIL the bottom, I'm going to get 3 times 3, which is 9. The outer and inner will sum to 0 because I'm going to get plus 3 root 2 and a minus 3 root 2, right? It's not an accident that the OI sums to 0. That's what's supposed to happen in a difference of squares, right? And then I'm going to get minus, and if you need to write a root 4 first, that's fine. If you can just get that root 2 times root 2 is a 2, that's great. So once I do that, clean it up a little bit, I have a negative 42 minus 14 root 2 on the top, and on the bottom, I seem to have a 9 minus a 2, which is a 7. Now, since 7 is a factor of both 42 and 14, I should probably clean this up, right? So this is a negative 42 over 7 minus a 14 over 7 with that root 2. So I end up getting that this is a negative 6 minus 2 root 2. And that's about as nice as it gets. All right, so I have a challenge problem for you. We're going to fully simplify the rational expression so that there's no roots in the denominator. So here I have a sum, right? And here they're already a and b, which I get can be confusing, but I want to create a difference of squares. So to do that, I'm going to do a minus b root 2, right? I'm just changing the sign between the two terms, right, to create a difference of squares. So the top is going to be a minus b root 2. And when I FOIL the bottom, I'm going to get a times a, which is a squared. The outer is going to be minus ab root 2. The inner is going to be a plus ab root 2, right? Remember, that's the big hallmark of a difference of squares. The OI sums to 0, right? The OI sums to 0. And then I'm going to get that this is a minus a b times a b, so that'd be b squared, and a root 2 times a root 2, which seems to be a 2. So I'm pretty sure my final answer is a minus b root 2 all over a squared minus 2b squared. And that is about as good as it gets. All right, and that's it for this video.